Okay. Well, now that we started a little bit late, I have to stop a little bit early. Just a few minutes, like maybe 8 minutes early. I have to get across town real quick. So it'll be all good. I'll make sure I give you a hard assignment. So just a quick review. Last time we talked about callback patterns. Today we want to talk about events and emitters. So right at the end of class last time we were dealing with this green and red light dealy flippy thing. Earlier in the class last time we talked about input-output streams, creating our own streams, right? So then we started talking about these callbacks, like things that get called when certain things happen. So we were registering guys as listeners. And we're going to talk about the next kind of evolution of that here in a few minutes. But just as a quick review, so we had our control panel, and this guy had a function called, well, he had a variable, a field called onClick callback. When we built this guy, he's associated with it was an event called onClick, and we associate a callback with that, where he just set his own callback variable equal to that callback. And then we had another event called click. This is when a button's actually clicked. And when you click it, you pass in the color of the button. And what it does is it calls back, it calls the function with the correct color. Okay, so then down here was an example where we had an instance of control panel. We set the click to take in a function that takes in a status, and it just says received click callback, and then outputs the status. That's on click. So when we create our control panel and then we said click green, click red, it's coming in here. We're passing in green and red as button color. As long as we have a callback set, if the button color was green, we're going to call our onClick callback and just say all okay. That's this guy up here. And he should spit out registered click callback, and then actually, no, where is it? Green comes here, so we're going to pass in green, so it should say registered click callback for each of these guys, then received click callback when they hit green and hit red. All right, so kind of the high-level model of these callbacks, but this is kind of a disjointed manual way of doing it. So kind of the next section is when we do this kind of automated. So we have these idea of events, emitters, and listeners. So emitters are dudes who raise events. Listeners are dudes who are interested in hearing about events. And events are the things that these guys are emitting and listening to. Okay? So kind of a code example here. They're dealing with the music player thing. So this is actually, we're dealing with the evolution of these things, because in the one right before, this callback pattern, this was the really crappy way of doing it. This is the old way, but the really crappy way. This is just somewhat of a crappy way we're about to look at. Then we're going to look at the node way of doing it. Okay? This is the node way of doing it if we wanted it to be. But there's a better, a most bestest node way of doing it. See, the Brazilian guys didn't even get that was bad English. You feeling better? Yeah. You were the sick one. Who else would not be feeling well? Right. Old Alex, how you feeling?
Great.
You didn't have diarrhea, did you? Yeah, you did. Make sure you didn't, keep me in the loop. All right. So, in any case, here's our object for music player, and basically this guy just has a field called the listeners, or called listeners. Right now, this is a dictionary of listeners that will be associated with events. Okay, so events are things like a button was clicked, or something started, or something stopped. These are events that we might be interested in. Okay, so a music player by default has a dictionary that holds listeners, but by default he has no listeners. So we're going to be adding listeners to this. Okay, then for the on function for the prototype, we're going to have a function that takes in an event name and a listener. Okay? If he doesn't already have a listener for that event name, then he's going to set up a new list of listeners for the listeners at position event name. So remember, a dictionary is a name value pair. Okay, so event name would be like, for instance, on-click. So if this guy doesn't already know how to respond to an on-click event, we're going to add to bucket on-click inside the listeners a list containing right now just the one listener that we sent in. Okay? But if he already does know how to respond to an on-click event, which means that previously this guy has already had a listener registered with him for on-click, we will fail this if statement and come in here and we will instead go to our dictionary of listeners, grab the list of listeners associated with this particular event name, and then add on to that list our additional listener. Okay, so for instance, we might decide that there's multiple things that we want to do in the event of an on-click. Okay, that makes sense? So that's what this guy is all about, this on thing, and you'll see it being used here in a minute down below. All right, then we have, so these are on events, on this, on that, on the next thing. That's what this guy is for. Okay, so we set up the generic event name and listener. Here's the emit. This gives a music player the ability to call out, to raise events. Yeah, emits, I think raise events is legitimate enough. Okay, so this guy, he takes in an event name that gets raised. Okay. If he doesn't know how to respond, if this particular music player doesn't know how to respond to that event, we just return. We don't do anything. Otherwise, we're going to create a local list of arguments. What gets passed into emit is going to be some, what we can call them command line arguments right now. We'll see it as an example down here below in a second. Okay, but we're going to create a local list of arguments. We're going to loop through all the arguments that were passed in and just add them to our list of arguments. So we're just creating ourselves a local copy of the command line arguments, the arguments that were sent along with this event. Then we're looping through all of the listeners associated with the particular event that's being emitted. Make sense? So if I am an instance of music player and somebody raised the start event, start playing event, something like that, and I have, so let's say it's me and Amish. Okay, we're both music players, and the machine, we just, oh, there's a new nickname. By the way, it's called, his name's the Machine.
Who?
Tim.
Is there an explanation?
There actually is, but I'm not going to tell it to you.
I need to hear it. It needs to be video.
It's clear. He's the Machine. I don't know what else to say. In any case, so the machine's going to raise an event. So he's going to raise the on-click event, or no, music started event. Okay. We're both music players, and let's just say that Amish in this case doesn't care about the music started event. So he doesn't actually have that event in his list, and therefore he has no listeners. Doesn't believe in music, right? Yeah. Huh? Except when music's no, you don't care in this case. You might react to other events, but not the music started event. You don't have listeners for that. But I have multiple listeners associated with that event. Okay, so when we come through Amish's instance of emit, music player, he's going to see that, oh, I don't even know how to respond to that event, so I'm done. That's going to be Amish. On the other hand, I do know how to respond to it. I know how to deal with that event name. So I'm going to go through, I'll grab all the command line arguments, we'll see that in a second. Then I'm going to go through all of the listeners associated with the music started event. And for each one of those, I'm going to, I'm going to store it inside of a variable called listener. And then I'm going to apply those arguments to that listener. So the listener is a function. we apply parameters to a function. Okay? And we'll see this in the example here in a second. So for me, since I had two separate listeners, I'm going to actually call two separate functions in response to the machine's raising of the event. Amish is going to do nothing. He just returns. Okay? Now we have a real example down here. So we're going to create a instance of music player, and they just called it player. All right, and now we're going to register some events. That's this on thing up here, this guy. So we're going to say player.on start, and we're going to associate a function with this. So it's going to take in an artist and a song, two parameters, and when that happens, when this event is raised, then we're going to write out starting audio stream playing artist and song. Playing artist and song. All right. Similarly, we will register the stop event. No argument function, stopping audio stream. We will register start again. This is a second listener we're associating with that start event. And we're going to say updating UI to start state, whatever that means. We want to make this connection that we're actually solving a real problem somewhere over here, creating a website or updating the UI for an app, whatever it is. Okay, so now we take associated with start for player. He has two functions. He has one that takes an artist and a song, and he has another one that takes no parameters and just spits out to the screen updating UI to start state, to started state. Then we have another stop function. This one says updating UI to stop state. Okay, now we're emitting parameters. We're emitting events rather. So we're going to say player.emit, and here's start. So we emitted that event. And now player knows how to respond to those events. But notice in this case, two parameters are being passed in. So Slater Kinney and No Cities to Love. Is that a real person? I don't listen to music. All right, let's just assume no. Okay, and then we have player emit stop. So when, it is. So player emit start. What this is going to do is it's going to emit something. It's going to emit the start event. So we come here to emit. The event name will be start. Does player have the have a property associated with start? He does. So we're going to get past that if. We're going to read in all of our command line arguments. So arguments here is prepackaged for us, and it came with these two parameters. Slater Kinney and No Cities to Love. Those are the parameters that were passed in. And we're going to copy those parameters locally into this list called args. All right, then we're going to just go through, and so this is the copying. These lines right here just copy those arguments into that list. Now we're going to go through all of our listeners for start. In this case, we have two separate listeners. We have this listener that we created and this listener that we created. And for each of those, we're going to apply our arguments. Okay? Null is actually its ability to pass himself in. We'll see another example of that probably later today, but if not, next time. Okay, but we're passing those arguments in. So the first listener we come upon is going to be this guy. This is the function that we added first. What's this called, Abe? When we have a closure, good. Boom. 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 All right.
Got anything else for me? No, I'm just kidding.
All right. So for this first one, this function takes in two parameters, an artist and a song. We just happen to have two parameters that are stored inside of args now, and it'll pass it in and saying starting audio stream playing, artist and song. Okay, so it'll log those things out to the screen. Then it's going to loop back around this guy to get to the second event, the second function, second listener, I guess is the best way of putting it, which is this guy. So here's the closer associated with that. This guy takes no parameters. We're going to pass it parameters anyways. It's just not going to use them. Okay, so it'll take in our two arguments. This guy won't use those, and he's just going to spit out updating UI to started state. All right. Similarly, we have stop. So here we emit the stop function. We didn't bother sending any command line arguments because neither of the stops take any command line arguments. And so this guy handles it that way. Okay. So we have something, and this is more of an object or a programming design pattern. In 370, you guys, software engineering class, you guys may have mentioned, I don't know if you go into it very much, but you may have mentioned this idea of design patterns at some point. Is that a true statement? Okay. Tell me what you know about these guys. What would you say a design pattern is? There's your next question, Abe. You have to pattern your design. Okay, that makes sense. You're absolutely right. So when we think about solving problems, we've heard of the term best practices, right? Best practices is kind of like a, I don't know, kind of official way of just saying it's the kind of the smart way of doing it. Okay. So typically we would say that when we're doing solutions to problems, if there is some sort of standard, that would fall into best practices, right? As opposed to making up our own solution. So like if you can like buy an actually made boat as opposed to building an inflatable thing with a wood floor, it probably makes more sense. So, in any case, what's up? Like that. See, it's a trick of the pros. I've been doing this a while. There was something I was teaching earlier, and this one of my Thinkful mentor sessions, and this guy was moving into a new house. I actually worked that into the lesson. I don't even remember how now, but it was awesome. Whatever I did, I blacked out for at least 15 minutes and just right in there. All right, so what was I talking about? Where am I?
Just right in there. That was the lesson.
I got to take my hat off. Okay, so.
I figured it. I was going to ask earlier, but
just made the assumption.
Mm-hmm.
Yeah, we're debating right now because I'm picking up my new car today. My wife doesn't want. Yeah, there was an incident.
Yeah, so I had to take the hitch off his.
All right, so I'll just tell this real quick. So I had him put a tow hitch on my car to pull my boat the other day. Mm-hmm. The very next morning, Ford calls me saying that somebody's in the market for a used Ford Flex. And my vehicle's leased, and they knew I had sold my company, so I don't have to have a leased vehicle anymore. If you own a company, leasing a vehicle lets you write stuff off. But if you don't own a company, leasing it doesn't do much for you. So anyways, I went in there. I'm like way over miles. Like I think I bought 31,500 miles with a lease, and I'm at like 36,000 miles, and I have like over a year left on lease. So I'm way over on miles. Well, so they decided, this would be good for the person. So they sold me a brand new Flex, that same color and everything, but has the tow package and all the stuff I need that he had already done. But I'm picking that up today. But I'm deciding if I want to put the Awesome Pat logos all over it. Mm-hmm. I mean, it seems like people know me by my car, right?
Yeah.
My wife does not want that. She has informed me that that's an embarrassment. That she's embarrassed to be seen in public with me driving around in the Fatmobile.
You should give her the option to either get it on your new car or put it on her Honda.
I should introduce her to the machine.
He won't survive.
Hey, look, it wasn't my idea. It was the machine's. Oh, that nickname's gonna stick. Huh? What, the machine? You know this one?
I know if it's the Russian machine story.
Yeah, it is.
I remember the story. It took a while. I remember.
It's a good one. So I'm picking that up today. That's, I guess, the story. So he had to pull the hitch that he spent time putting on. He had to pull it off.
At least it didn't take a while to put on. 45 minutes.
Yeah.
It's not 3 hours.
But now I don't have to worry about mileage. I can put as many miles on this one as I want.
Yeah.
Road trip.
Plus, the suspension hasn't sounded right since we went to that Dice.com hackathon. You guys overweighted that thing in the back. Popped a spring or something. All right. So in any case, we were talking about design patterns. So there's kind of standards, and there's several kind of stock standards in computer science problem solving, and these are kind of globally maybe called design patterns, kind of the way that we accomplish these things. And one of these design patterns is this idea of the observer. Okay, so the observer is a design pattern that lives inside the event listener model. So the idea is this isn't really dissimilar to real life. You know, if I say, hey, be on the lookout for a blue Chevy pulling in, you now become an observer, right? You're going to stand there in the parking lot and you're going to observe every car that's coming in. And as soon as you see a blue Chevy, you're going to yell. You're going to raise an event. I saw it. Okay, that's the observer design pattern. Nothing special, just design pattern sounds fancy, and you guys didn't pay attention to software engineering. So, in any case, the way the observer design pattern is implemented in Node, it's built into something called the event emitter. Okay, so we just did kind of this is the ghetto version of this guy where we did everything manually. Not a big deal, but we'll see that we can accomplish this exact same thing down here in just this code. Okay, so we're going to kind of walk through that. So the first thing we need is this, it's a library called events. And then we're going to associate with player. So notice up here, player was an instance of music player. So this is really an object-oriented approach, which becomes a little weird for us because we're used to object-oriented languages. So we're kind of like, oh, I like to build objects and associate things with those objects. That kind of makes sense. But the reality is that all this crap we did in here, we attached to an object just because that was the only way that made sense to us because we're object-oriented programmers. The reality is we're just creating this idea of an event model. It really has nothing to do with this music player object. Okay, we just built the music player. We could have called it music player, music listener, whatever we wanted to do. We built it as a means to an end. Or down here, instead of player being an instance of music player, they're saying player is an instance of an event emitter, something that built into the node emitter, node events library. Okay, and then what we can do is with player, we can say on start, here's a function, and this is what it does. Same thing as we had above. We wrote this guy. We wrote this guy. So notice that this guy we had to write by hand up here is built into event emitter. So we can assume that on is there, and we can assume that emit is there. That model is supported with on an event and emit an event. So once we have an instance of event emitter, we can associate this function with start, this function with stop, this function with start, this function with stop, and then we can emit the same things as we had before. So notice that all those details that we had written up here inside of our music player class, this guy up here, all that stuff up there is handled in this one line. Make sense? It's just built in. All right, so that is the observer model in Node, where we can listen for events and we can raise events. All right, so now events in series, and this starts getting into dealing with APIs. So this is kind of putting together several of things we've talked about up to this point, where we used UniRest for talking to RESTful APIs, getting our JSON crap, right? We used Express, that's our web server, when we wanted to make a little simple web server. And then we just recently used events, just in the last 10 minutes, to do event crap. Okay? Emitters and listeners. So now we're going to use these three things together to actually accomplish something a little more real. Not totally real, but a little more real. All right, so here's where we're talking to some API. In this case, they're talking to Spotify. So some endpoint at Spotify. Do they actually tell us out here? So this is a function, get from API. The function is going to take in an endpoint and a set of arguments. Okay, so we're going to create an emitter. That emitter is going to be our event emitter, just like we did with the player up above. Then we're going to go ahead and access our endpoint. So this is our network connectivity thing. So we'll hit api.spotify.com/v1/ whatever endpoint they passed in. Okay, whatever they called. I'm sure they probably give an example later on. I think they did. Okay, so we'll go ahead and access that. We'll then pass it, the arguments, and then when it's over on end, we have our response, and we will emit the event that it's ended. For anybody who's observing, we have finished getting the information. That makes sense? So UniRest is going to say, I'm going to talk to the Spotify server at this specific endpoint, whatever this guy was asked to do. Let's say we're getting, whatever. It doesn't matter. We're going to send in the arguments, and then as soon as we get a response back, as soon as we are notified by UniRest that it's finished, so we get the end event, we're going to go ahead and create a function that's going to emit the end event, and with the body of the thing, which probably is going to be our JSON. That's usually what RESTful APIs return. So essentially what we're doing here, if all of you guys are observers in this model, okay, so all of you guys have registered that you are interested in knowing once I have received my JSON document from the from Spotify. As soon as this comes, I'm going to say, and I'm the emitter in this case, I'm going to say, I have the JSON. And all of you are going to perk up and you're going to say, okay, you want the JSON, and I already threw it at you, so think quick, right? Because here it is. Response.body is going to be the JSON that came back from the Spotify server. So all of you now have to catch it, okay? Except, of course, for Amish, who didn't register a listener.
You can't.
It's a habit. It's a habit. And then, of course, the machine who had the JSON before I requested it. All right. So down here is kind of where they're putting some of that together. So here's our web server. That's our Express guy for running our own little web servers, right? Here we have our own little API. So we're having a get endpoint for /search/ whatever name we want to pass in. This is our get response. So this is the stuff we did when you did like the little math problems. Had the, taking two parameters in, add them together and that kind of stuff. Okay. So we have an artist. This is a function. So, even though this says on search end, this is not actually registering a listener at this point. It's something that's going to be used to register a listener. So this function is the function that we're ultimately going to want to call when the person has finished searching. So it's going to be a function that takes in an item, sets artist equal to the item at bucket 0 from the item of artists. Okay, and then we're going to use the response .json to, actually not response, the RESTful JSON to parse artist. So this guy is going to be a JSON object of type, or whatever Spotify returns for an artist. Here's another function on error. So what's this guy going to do? Actually, no, this is the response. Yeah, it's this guy. This is the response. So this is response JSON. This is response send status. So this is spitting back to the server that something bad happened, error 404. You've seen those on web pages before, that kind of jazz. All right. Now, here's our search request. So we are getting from API. And where was that? That's this guy up here. Here's our function get from API. What are we getting from the API? Well, we're passing it search as our endpoint. The parameter we're passing it is this guy. And what kind of animal is that guy, Abe? What I have highlighted there. You can't blame me and say you can't see the highlighting. This one's pretty clear.
Yeah.
What kind of thing is that? Just
JSON?
it's JSON. Yeah, it's JSON. So this guy's expecting the arguments, so he wants the endpoint and the arguments. And the arguments that we're sending here, well, the endpoint we're sending is search. The arguments is a JSON object. So we are searching for a name. We're going to limit the response to 1 of type artist. Okay? So that's what we're sending as parameters to get from API. Then we're going to register for both the end and the error events. This is search request, this guy. So this guy is interested in knowing as soon as this get from API finishes. That's what happens right up here. So when this guy finishes getting that information, he's going to emit the end, letting everybody know that he's finished. Search request, this guy has registered to observe that event, the end event. He's also interested in knowing if something bad happened. 2 different errors. Okay? Remember, the whole thing we're trying to do here is asynchronous communication. Search request is not sitting here looking over this guy's shoulder constantly, micromanaging him. He's just chilling, waiting for this guy to scream end or error. All right, so he's going to register for both of those events, and then we start our listener. And what we can do here, actually steal some of this code. Okay, so if I run this and we go to /search name, so we're searching for the name of an artist. Seems like that should probably, well, we got to come up with a good artist to search for. All right, so let's start our server. I'm going to save that. Go to terminal. Okay, so it's listening. We're going to go to port 8080 of our local host, /search, and then we need to give it a name. So this is localhost 8080. That was the port we picked, right? Yep, 8080. /search, and then who are we searching for? Clay Aiken? Uh-oh. Let's see, can I do 2 things? Let's just do a search for Clay. Cannot get /search/Clay. Why? Let's see if we have an error out here. No, it's running. This guy is called server, isn't it? No, it's called cache. So yeah, I just randomly dropped the code into something we wrote last time. So I'm not even running our server right now. We need to run cache.js. Oh, I need to install unirest. What is it? npm save install unirest. grep npm. Ah, there we go. We had done it, but we had done it when we were still doing this on Nitrous, right? I think that's when we had unirest on there. Okay, so it has it now. I didn't define server anywhere. This is what happens when you just copy somebody else's code. They probably did it up top here. Yeah, it looks like app, not server. Okay. Localhost. Clay. Okay, here we go. So we got genres. We actually have a name somewhere. Well, this gives us just the URL. Let's see which guy this found. Which version of Clay this found. Oh, Willie Clay Band is what it found.
Yeah, that's way down at the bottom.
Yeah. Where's his name, Willie Clay Band?
Oh. Aha! Oh, there's Clay Aiken. Let's find some pictures. Where's the images? Images. Invalid ID.
You forgot a.
Oh, I have all this extra crap. I don't like that very much at all. Can't give me better stuff than that.
What about the next link?
Aha!
Amish
He just
seems-
lost like a race for Senate.
Amish seems like you've searched on this for Clay Aiken.
Why'd you know that was the right link?
Yeah.
It's like, don't get all defensive, machine.
I'm getting
All right.
worried.
So, what we want to do let's see. Let's do. That's not the weather one I wanted.
Say you had to leave 8 minutes early, so
Is that it?
that's what I heard.
Well, I
I
got it.
heard you specifically say if I'm running 8 minutes, I'm not done giving you your homework.
Okay, fine.
You have to
Fine.
get gas in your
Remind me, beginning of next class, this is your homework. Remind me, beginning of next class, I want to implement the start of something with the weather API. And then for your homework, you're going to be doing something to extend that. So I'll give you the first part of it next class. All right, so you'll have something to operate off of. And then that will be due on Friday, and the next week's the final, right? That sounds right? Okay, so we'll talk about the final exam on Friday, so you kind of know what to expect and all that jazz. All right, see you when I see you.